Okay, very good, very good. All right, well, Bernie, I really appreciate the opportunity to talk about our research and share some of our recent developments. Oops. Okay, there we go. First thing I want to do is talk about SWAT Plus. We have some new routines in SWAT Plus that I think will help spatially represent wetlands. SWAT is a watershed scale model where we typically look at larger scale watersheds beyond the point that Dennis was talking about, much larger scale. One of the things we've done in SWAT is recode it. We're using the Fortran objects and modules. It's just easier code to maintain and support and add new processes to. We're also doing in SWAT Plus a much better job of version control. We're using Bitbucket and we're archiving code and data with that code. And again, it's just a much cleaner code, easier for me to maintain and support. Okay. In addition to the restructuring, we've totally restructured the input and output files. I'll talk about that in just a few minutes. We have improved some of the water cycle, nutrient, plant growth, and so on. But at this point, most of the processes are very similar to SWAT. I'll talk about that more in a few minutes. But we're just continuously improving and updating as we go over the last few years with SWAT Plus. The main difference in SWAT Plus is the representation of the connectivity. And instead of in SWAT, everything was based on a subbasin, the channel HRUs, the weather was all tied to a subbasin. Now what we've done is each spatial object is a module. The channels, the wetlands, the aquifers, the HRUs are all separate objects. So we have a lot more flexibility in how we can connect those. We have a connect file for each object. So we can say this field, the tile flow from the field can go directly to a wetland. The surface runoff, 50% can go to a channel. The other 50% runoff overland. So just a lot more flexibility in SWAT Plus than what we had in SWAT. And what that allows us to do, it makes it much easier for us to divide a basin into fields or grids. It's much easier to realistically represent those first order streams and what's coming into the smaller order streams and ditches. In our GIS interface for SWAT Plus, we can delineate floodplains now and look at the stream floodplain or riparian zone interaction. So it's allowed us to downscale in a much more realistic way. Just very briefly on the input file structure, we've gone to more of a relational input database structure now, which makes sense. We just instead of having a little ASCII file for each soil, we have it in a soil data file now, and the HRU just points to it. It allows us to maintain those as databases and use crowdsourcing. The other thing I do want to talk about briefly is our use of decision tables, and it's just a precise, fairly compact way to model rule sets and their corresponding actions. I'll talk a little bit more about some of the ways we're using decision tables. We're using them reservoir release, land management, land use change, and several areas. The land processes really haven't changed much. We've done work in the last few years with carbon budgets and carbon dynamics. We've also, Ryan Bailey at Colorado State has added salt transport routines and the impact on plant growth. But the pesticide dynamics, pathogens are all pretty much the way they were in SWAT. We've got the output files I think are easier for users to understand and to analyze. Basically the same management that we've had in SWAT all along. The last few years we have done, our main emphasis really has been on tile drainage water management. We've looked at controlled drainage, saturated buffers, moving from one tile in the field to a tile in the saturated buffer. So that's been something that we've done quite a bit of work on lately. As far as the hydrologic balance, the only real change in the hydrologic balance is that we've separated the HRU from the aquifer. So they're separate objects now, separate spatial objects, and the percolation from the bottom of the soil, it goes into the aquifer, and we have to tell it in the connect files which aquifer to go to. So that gives us again more freedom on how we represent the subsurface areas. The plant growth is EPIC, based from the old EPIC model. On a daily basis, we estimate potential growth, and we have constraints for water, aeration, temperature, N&P. And I've done a lot of updating recently on the aeration stresses, and I'm at the point where we feel pretty good about that. Pesticide processes are still our gleams. We're using the gleams type approach with foliar and soil half-lives. We do estimate how much is coming in the lateral flow and in the tile flow, and how much is available to leach ultimately into the aquifer. As far as watershed applications, we have worked with Mike Winchell on applying, if we have, say, 100 fields in a watershed, instead of applying all the pesticides on one day, we can randomly apply over a time period, which we think is more realistic. And Mike Winchell and his group have done some testing of that. Some of the in-stream pesticide processes, we have a model. It's a first order type model with simple coefficients. That's something Steve Chapper developed years ago, and we've included it and updated it over the years. We assume the water body is well mixed, and we do track how much is in the sediment and the interactions with the sediment and the water column. Just briefly on the sediment transport, we're using modified USLE. So we're just predicting the sediment yield at the edge of the field, at the outlet of the field. We don't do the deposition and erosion across the hill slope as Dennis does in WEP. The channel erosion, we've gone to more of a morphology of down cutting and widening. We're trying to parameterize that across the country, and D50 and some of the parameters have been a challenge, but we're currently working on that. The wetland deposition, we have a settling velocity based on particle size of that area. And the other thing we can do in SWAT Plus is we can, again, delineate floodplains, riparian zones, and simulate the stream floodplain interaction with if there is a wetland in the riparian zone, and how that sediment is deposited in the wetland. Okay, the wetlands themselves are just simply HRUs, which is the soil. We do have plant growth that can pond water. The inflow, as we talked about, is from the connect file, so we can have inflow from any HRU. Again, tile flow, any component of that runoff. We're working again with Ryan Bailey to have a more realistic groundwater interaction with the wetlands. Right now, it's the groundwater connection isn't as realistic as it probably should be. So that's something we've just started working on recently. Outflow, any outflow from the wetland is from a decision table, and we can condition that outflow on volumes, the season, really any state variable in SWAT. And we have a simple N&P settling rates that were developed by scientists at Iowa State. Okay, some of the wetland process, the pesticide process is very similar, basically the same algorithms as the channel processes. Just keeping track of the degradation, the volatilization in the water column, and the interactions with the pesticides. Again, first order single coefficient type processes. One thing we have done, we've taken the GLEAMS pesticide database, and Mike Winchell and his group have come up with some of the aqueous parameters, and we've included those all in one data file now for each of the pesticides parameterized in GLEAMS. Okay, I want to spend just a few minutes talking about a national model that we've been working on to finish up my presentation. We worked on a SEEP, a watershed version of SEEP, which is a USDA program to inform policy for conservation policy and funding. And we learned a couple lessons in SEEP 1. We were looking at a Huck 8 scale. We're lumping within a Huck 8, and we realized we didn't have the spatial detail we really needed at that point. We also, at the watershed scale, we couldn't share some of our output because some of the inputs were from survey data, and we couldn't share those directly. So what we've done in our next version of SEEP, our next national model, is actually get down to the field scale, and just briefly to describe that, we're each Huck 8 is a SWAT model run. Each Huck 12 is a sub-base, and we do some lumping within those Huck 12s. Those are 100 square kilometers or less. And across the country, we have about 7.5 million HRUs. For the cultivated ag areas, we're using field boundaries developed by scientists at South Dakota State. We have just over 4 million fields. And this gives you an idea of what that field map looks like. The figure on the right is a Huck 12, and it shows you some of the, and this is a heavy ag area, obviously, and some of the field distribution within a Huck 12. On the hydrography side, we're using NHD Plus version 2. We're modeling about 3 million reaches. This is a Huck 8, and it gives you an idea of the detail that we're going down to, just compared to our SEEP 1, a lot more spatial detail, and we can look at processes, especially sediment processes at a much smaller scale. This is an ARS watershed we've been monitoring in Missouri. It's a Huck 12. I just want to give you an idea of the fields, some of the variability in runoff between those fields, and how the streams capture the runoff as we move downstream. Now we have had the NHD Plus still has a lot of connectivity issues. Mike White, ARS scientist at our lab, has gone through and I think cleaned up most of those issues, working with USGS, at least at the Huck 12 scale and above. So we're starting to feel better about the NHD data set that we're using. Just wanted to give you an idea of the scale of some of the fields. This is Iroquois County in Illinois, about 8,000 fields we're modeling. And we've taken a pretty hard look at corn and soybeans, and trying to calibrate those. The status of the national model and the calibration, we looked at water budgets. We're forcing the Huck 8s to match a water budget, the ET, surface runoff, base flow, tile flow from USGS data. We allow the model to handle the variability within those Huck 8s, but we're just trying to do the means. We're finishing up the corn and soybean crop yield soft calibration across the country. Again, it's a Huck 8 scale. We've got about 3,000 stream channels where we've got load data, sparrow data on NNP and sediment that we've looked at means. Now we're looking at monthly and daily calibration at that point. at this point, we're just really starting the sediment calibration, and hopefully we can start some of the nutrient work, hopefully early next year. So that's where we're at with our national model. And with that, Bernie, hopefully I left a little time. Hopefully I left a little time for questions.
You did. Thanks, Jeff. So we've got several minutes for questions. So questions for Jeff. So Jeff, you know, it was interesting to hear you talking about some of the national initiatives with this recently. So what, you know, what's the timeline to see, you know, some of these sort of play out and become more available for use by a breadth of groups that are represented on the meeting today?
We've started sharing it with some research groups. University of Illinois, 2 or 3 universities around the country that are doing some more detailed calibration and such. We're really at the point now where we feel pretty good about water and plant growth, and we're just really moving ahead now with sediment budgets and nutrient budgets. So it's, you know, again, it's open. We're happy to share it at this point with anybody that's interested. It's fairly easy to share a Huc-8 data set. So, and I think it would be, you know, you could go in and add pesticide applications or apply it in at that point in any way you'd like to.
So someone else with a question for Jeff? We do have another minute. I'm going to go ahead and shift to the other slides so we can get ready for that, but ask a question if someone would.
Hey, Jeff, this is Mike Winchell. Just wanted to comment on something you had mentioned there in the presentation about the decision tables and how that's like a new feature in SWAT Plus. And that's something that we found to be really, really helpful in terms of pesticide applications, because you can define logic and rules as to when you can and cannot apply a pesticide. And also, as you mentioned, Jeff, also distributed across times across different fields. So that's a nice built-in feature, I thought, for SWAT Plus. And the other thing that I thought was a really big improvement that you guys did was just the whole connectivity and ability to route the different landscape units. It kind of works really well for example, routing a field through a buffer, vegetated buffer or riparian buffer before it goes into the channel. Almost kind of linking what you might have with like a BFS mod type model, but within the SWAT type of construct. Just a comment.
Yeah, and that's been really that's the major difference as far as processes go in SWAT Plus. Just the capability to configure the watershed and move water around. And again, I appreciate your help with decision tables and testing that and getting that, because I think that is important, especially at the watershed scale, that we more realistically apply the pesticides across the watershed.
All right, thank you much, Jeff. I think Renee is ready to share the next talk, and Pat, you can request control, and that way you'll be able to drive. So Jeff, thanks again. Looks like a lot of great things going with WEP and a lot of great things going with SWAT. So appreciate the presentation. So